Combination of resistors, series and parallel. Resistance in the circuit can be grouped into following ways. 1. In series. In series connection of resistors, they connect in such a way that the same current will flow through each resistor when some potential difference is applied across the connection. If R1, R2 are the two resistors which are connected in series connection as shown in the figure, V1, V2 are the potential drop across each resistor, then according to Ohm's law, potential difference across R1 is equal to V1 is equal to IR1 and potential difference across R2 is equal to V2 is equal to IR2. The potential difference V across the combination is V1 plus V2. Hence, V is equal to V1 plus V2 is equal to I R1 plus R2. Thus, the equivalent resistance of the circuit can be given by R EQ is equal to R1 plus R2. The equivalent resistance of the total resistance in the circuit will be greater than the greater resistance in the circuit. 2. In parallel. In parallel connection of resistors, they connect in such a way that the current flowing through each resistor will be different, but potential drop across every resistance is same. If R1, R2, R3 are the three resistors which are connected in parallel connection as shown in the figure, I1, I2, I3 are the current passing from each resistor, then according to Ohm's law, I is equal to I1 plus I2 plus I3. Here, potential difference across each resistor is V. Therefore, V is equal to I1 R1 is equal to I2 R2 is equal to I3 R3, or I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. Putting values, we get I is equal to V by R1 plus V by R2 plus V by R3. Thus, the equivalent resistance of the circuit can be given by V is equal to IRP, or I is equal to V by RP. V by RP is equal to V by R1 plus V by R2 plus V by R3, or 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. The equivalent resistance of the total resistance in the circuit will be smaller than the smallest resistor in the circuit.